Hey everyone, hope you're all well. Welcome back to our channel, and in today's video we are diving into a crucial aspect of the development process, which is testing and deploying your web applications. Whether you're a seasoned coder or just starting out your coding adventure, understanding how effectively to test and deploy your web application can make or break the success of your web application as well. In today's guide we will go over the importance of testing, we'll go over test-driven development, different kinds of testing, and actually how to deploy web applications. So without further ado, let's get started. So testing web applications is a really crucial step in the software development lifecycle for several important reasons. Testing will help uncover and fix bugs, errors, and other issues in the code. This ensures that the application behaves as intended and provides a positive user experience. Testing verifies that all features and functionalities of the web application work correctly. It makes sure that the user can perform the expected actions without encountering unexpected behavior. A well-tested application will follow all security measures, so testing is essential for identifying and fixing any security vulnerabilities. It helps in ensuring that sensitive user data is protected and that the application is resilient against common security threats. Web applications need to work consistently across various devices, browsers, and operating systems, so testing can help you identify and address any compatibility issues, so you have a broader reach for your application. And it also allows developers to assess the performance of their application, and this includes evaluating its responsiveness, load times, web accessibility, and overall efficiency. Addressing performance issues leads to a more reliable and faster application. And users are more likely to trust and continue using an application that works reliably. Testing can help build trust with your user base by delivering high quality products that meets their expectation as well. In summary, it's a really proactive approach to quality assurance, ensuring that web applications meet high standards of functionality, security, and performance is an integral part of the development process that contributes to an overall success of the application. So now let's talk about TDD, otherwise known as test-driven development. Test-driven development is essentially a software development process that revolves around writing, failing automated tests before writing any production code. It's a very cyclical process, and it involves writing a failing unit test. So this test should describe the desired functionality of the code to be written, writing the minimum amount of code to pass the test. This code should be simple and straightforward as possible. Refactoring the code. This involves improving the code without changing its functionality. And then keep on repeating steps 1 to 3 until this feature is complete. It can be used in any type of software development, but it's particularly well suited for web development because web applications are typically composed of many small independent components, making them easy to test in isolation. So to get started with TDD in web development, you actually first need to choose a testing framework. A testing framework is a set of guidelines, tools, and libraries to help testers to automate the testing processes. It provides common structure for writing and executing test cases, and it can help reduce the time and effort needed to test software. There's a lot of different types of testing frameworks available, but they all share common features. Things like a way to organize and manage test cases, a way to execute test cases, a way to report on results. That can be done in a variety of ways, like generating a report or sending an email notification. Testing frameworks can be used to automate all types of software testing, including unit testing, integration testing, system testing, and acceptance testing. They can be used to automate different types of tests, like functional tests, performance tests, and security tests. Some benefits of using a testing framework include increased efficiency and productivity. That's because testing frameworks can help tests to automate many of repetitive tasks involved in testing software. This can free up testers to focus on more complex tasks, like designing and executing test cases. Testing frameworks can also help improve the accuracy and reliability of testing because it provides a consistent structure for writing and executing test cases. And testing frameworks can help reduce the costs of testing by reducing the time and effort required to test the software. Once you have chosen a testing framework, you can start writing tests for your web application. The best way is to focus on the smallest, most independent component of your application. So for example, if you're developing a shopping cart application, you might want to start by writing tests for individual components of the shopping cart, for example, the product list, the cart itself, and the checkout process. Once you have written tests for the individual components of your application, you can start integrating them together and writing tests for the overall functionality of your application. TDD can be a challenging process to learn at first, but it's a very valuable skill for any web developer to have. With practice, you will find that TDD will help write better code and write code with fewer bugs. So there are a few popular testing frameworks for web development. We'll go over some of them today. The first one is Cypress. Cypress is a JavaScript-based end-to-end testing framework that's designed to be easy to use and debug. It's a newer testing framework, but it's become really popular due to its unique features and benefits. One of the key features of Cypress is that it runs tests in a real browser without the need for third-party drivers. This makes it really easy to write tests that mimic real user interactions. Cypress also provides a number of features that make it easy to debug tests, like the interactive test runner, snapshot testing, and error reporting as well. Cypress can be used to test all types of web applications, including single-page applications, progressive web applications, and also well integrated with popular JavaScript frameworks like React, Angular, and Vue. It's a really powerful and versatile testing framework and can be used to test all types of website applications. Really easy to use, debug, and integrates well with popular JavaScript frameworks. If you are developing web applications, I recommend using Cypress to test your code. It will help you to catch bugs early on and improve the quality of your applications. Next up is Mocha. So Mocha is a JavaScript testing framework that's really similar to Jest, but it's more flexible and extensible. It's also one of the oldest and most popular testing frameworks for JavaScript development. Mocha has a number of features that make it a really good choice for JavaScript testing, including flexibility, extensibility, support for multiple assertion libraries, and support for test coverage reporting as well. It can be used to test both synchronous and asynchronous code, and it also supports a number of features that make it really easy to write and maintain tests, like test suites, test runners, and hooks. Mocha is a really powerful and flexible testing framework and can be used to test all types of JavaScript applications. It's really easy to use, extensible, and provides a number of features that make it easy to write and maintain tests. They also can be used to test JavaScript applications. You can do unit testing to test individual units of code. You can also test how different units of code interact with each other. You can also test entire applications by simulating user interactions, and can be used to test APIs by sending and receiving requests and responses as well. If you are developing JavaScript applications, I recommend using Mocha to test your code. It's a really good choice for both beginners and experienced testers. Next, we have Jasmine, and Jasmine is another JavaScript testing framework, and it's known for its simple and readable syntax. It's also very lightweight. They don't have any external dependencies as well, so it's a good choice for projects of all sizes. It's really easy to use, it's readable, it's lightweight, and it's feature-rich. They have support for both synchronous and asynchronous code, support for test suites, test runners, and hooks, built-in assertion libraries, and support for test coverage reporting as well. Jasmine is a really powerful and versatile framework that can be used to test all types of JavaScript applications. It's easy to use, readable, lightweight, and feature-rich. If you are developing JavaScript applications, I highly recommend using Jasmine to test your code. It will help you write your code better and catch bugs a lot earlier on. So lastly, we have Jest, and Jest is a JavaScript framework that is designed to be simple, fast, and reliable. It's one of the most popular testing frameworks for JavaScript, and it's mainly used by large companies like Facebook, Airbnb, and Google. It's very easy to use. It's also very fast at running tests because it uses a virtual DOM to render components and tests, which is much faster than rendering components in a real browser. Jest is very reliable and rarely produces false positives or negatives, and has lots of features, making it a really powerful testing framework like snapshot testing, mocking, and code coverage reporting. Jest is really powerful, it's very fast and easy to use, and we'll take a closer look at getting started with Jest as well. So you can actually start installing Jest using the command line. You just want to make sure you have Node.js installed first. First, we are going to navigate to our desktop, and we are going to make a new folder on our desktop. And we'll call it Test Jest Framework. And now let's go inside the folder, and let's just open the code file. And just open a code editor. And you'll see the code editor open our test framework. And now what we're going to do is we are going to just open a default kind of JSON package. So what we're going to do, we're going to type in npm init --y. And you can see it's created a default JSON package. You'll see when we open the JSON package here, we've got the name, version, all of that. This is just a default JSON package. It's not anything to do with Jest just yet. This is just a default JSON package. So now let's actually install Jest with the npm command, and then install D Jest. It's going to take some time, maybe about 3 minutes. So I'm just going to create a file so that after this we install it, we can see that. So I'm just going to make a new file called sum.js, and I'm just going to create a function. And just a simple kind of function to run, so we have something to test. And Jest should be installed. Nope, just a few more. Yeah. And now if we go back to JSON, and we're just going to remove this here, this no test specified, and we're actually going to replace that with Jest. So this just means that we have to run the old test cases with Jest. Now the function that we created is also ready for the test, but there's still one more file that we need to create to actually test. So we'll go up here, create one more file, we'll call it sum.test.js. So first of all, let's just type in const sum equals, and then we'll do request require actually. So that we can get the test case. Great. And then we're going to add some text here. And we're going to call it test case. And we're going to add a new function. So in this parameter, and expect function as well. And here just put the sum, and also add the to be. And we expect the sum to be 3 because we wrote in our sum function return 1 plus 2, which is 3. So we are just going to write the to be function to be 3. So now our basic test case is ready. And we can see how we can run it. So to run it, we go back to the command line and we do npm run test. Yep, so we need to test this one test instead of track list. The autocorrect is not great. So now let's run this again. npm run test, and we'll run it one more time. And you can see it's working right now to test. And you just keep testing and trialing until you get the results that you need, and then you have that running continuous as well with Jest and testing that as well. So let's look at some advantages of using TDD in web development. The main one obviously being is that it does help improve the quality of your code, because it forces developers to think really carefully about the design and implementation of their code before they actually start writing it. This leads to cleaner and more modular and more testable code as well. TDD helps to catch bugs really early in the development process, which saves time and money in the long run. It gives developers a confidence that their code is working as expected. This can lead to faster development and a more positive development experience. TDD makes it easier to refactor code without introducing new bugs, and this is because the tests act as like a safety net, ensuring that the code still works after the refactoring is complete. And it can be used for documentation for the code as well. It can help other developers to understand how the code works and how to use it. TDD also helps to improve the performance of web applications, because it helps developers think carefully about their performance earlier on in the development process instead of leaving it last in the testing section. It can help reduce cross-browser compatibility issues because it forces developers to test their code in multiple browsers. And it can also help improve the accessibility of web applications because it forces developers to test their code with accessibility tools as well. Overall, it's a really valuable tool for web developers that can help improve the quality and performance and accessibility of web applications. So now let's talk a little bit more about the web development process and where TDD comes in. So what is the website development roadmap? The website development roadmap process, it involves several key steps, and essentially all of these steps make up the roadmap from conception all the way to launch. So here's a general overview. First up, we have project discovery, and this is the initial phase, and it involves understanding the client's goals, target audience, and project requirements. Discussions and brainstorming sessions help to clarify the scope, features, and overall vision for the website. Then there's the planning. So once the project objectives are clear, the development team outlines the project plan, including timelines, milestones, and resources. They decide on the technology stack, content structure, and design approach. The next phase is the design phase, and in this phase, designers create wireframes and mockups that visualize the website's layout, the interface, and user experience. Feedback and revisions refine the design until it aligns with the client's visions and the agency's capabilities. Next up, you actually have content creation, and content development starts including writing, imagery, videos, and other multimedia elements. Quality content is essential for engaging users and conveying the intended message. Next up is the development stage, and developers will then take the design and turn it into a functional website, and this involves coding, HTML, CSS, JavaScript, and any kind of background programming. They will build the interactive elements, the databases, and integrate any necessary third-party tools. Next is the testing phase. So rigorous testing is crucial to ensure the website works smoothly across various devices, browsers, and screen sizes. Bugs, glitches, and usability issues are identified and resolved during this phase. Then you have a client review. The client review is for the client to actually review the development website and provide any feedback. Any necessary adjustments are made before proceeding. As the website nears completion, preparations for launch begin, and this includes configuring hosting, domain setup, SSL certification, and any other technical requirements. And then you have the actual launch, and this is when the website is made live to the public, and this involves migrating the website to its final hosting environment, ensuring all links and functionalities are working correctly. And lastly, you have post-launch testing and optimization. After launch, ongoing testing continues to catch any issues that might arise once the site is live. Additionally, performance optimization and SEO efforts are undertaken to enhance user experience and visibility in search engines. Website maintenance and updates, and this should be offered sort of by agencies afterwards, but essentially websites require regular maintenance, including security updates, content updates, and feature enhancements. This phase ensures the website remains functional and up to date over time. And next up, we have analytics and monitoring. So continuous monitoring of website traffic and user behavior provides insights into how well the website is performing and where improvements can actually be made. So the specifics of each step can vary based on the complexity of the project and the practice of the development agency. This roadmap provides a sort of general outline of the website development process from start to finish. In the next few slides, we'll go over each of these phases in more detail. So when it comes to testing web applications and web platforms, you also want to do other types of testing as well. And one other type of testing you want to make sure of is accessibility testing. So what is website accessibility? Website accessibility refers to the inclusive design and development of websites and web content so that people with disabilities can perceive, understand, navigate, and interact with them effectively. The goal of website accessibility is to ensure that all users, regardless of their abilities, can access and use websites without facing barriers or limitations. When a website is accessible, it accommodates a wide range of disabilities, including visual, auditory, motor, and cognitive impairments. Some examples of disabilities that website accessibility addresses are visual impairments. So people who are blind or have low vision may use screen readers or other assistive technologies to navigate the website. Website accessibility ensures that all information is presented in a way that can be understood audibly or through alternative formats like Braille. Deaf or hard of hearing users may also rely on captions or transcripts for multimedia content. Accessible websites provide these alternatives to ensure equal access to audio information. Users with motor impairments might navigate websites using specialized keyboards or other adaptive devices. An accessible website should be navigable without requiring precise mouse movements or rapid keystrokes. People with cognitive challenges may benefit from simplified language, clear headings, and consistent navigation to comprehend and interact with content effectively. And individuals with conditions like epilepsy may be sensitive to certain visual or auditory stimuli, and accessibility guidelines aim to minimize potential triggers. Website accessibility is not only a moral imperative to create a more inclusive digital environment, but it's also mandated by laws and regulations in many countries. For example, in the US, the Americans with Disabilities Act, the ADA, and the Web Content Accessibility Guidelines, so the WCAG, provide standards and guidelines for website accessibility. Web developers can follow these guidelines and use various accessibility testing tools to ensure that their websites meet the required necessary criteria, making the internet a more accessible and equitable space for all users. So let's talk a little bit about the WCAG. As mentioned before, the WCAG essentially provide a comprehensive set of guidelines for making digital content accessible to people with disabilities. These guidelines are organized into 4 main principles, each with its own set of success criteria. First up, we have that the content should be perceivable. So this is things like providing text alternatives for non-text content, i.e. images, providing captions and other alternatives for multimedia, create content that can be presented in different ways without losing information, make text content readable and understandable. You also want to make sure that content is operable, and by this it means making sure all functionality is available from a keyboard, provide users enough time to read and use content, don't use content that causes seizures or physical discomfort, and provide ways to navigate, find content, and determine where they are. It's also important for content to be understandable, and that means making sure that the text content is readable and understandable, making sure web pages appear and operate in predictable ways, and help users avoid and correct mistakes. And lastly, the content must be robust. So essentially you want to maximize compatibility with current and future user agents and trends, including assistive technologies. Within each of these principles, there are specific success criteria that provide detailed guidelines for making content accessible. Some examples of these criteria include ensuring that images have descriptive alt text, providing captions and transcripts for videos, using sufficient color contrast for text and background, ensuring that all functionality can be accessed using a keyboard, and providing clear, consistent headings for content structure. These are just a few examples, and there are many more success criteria under each principle. The WCAG guidelines are designed to be adaptable to different technologies and are meant to provide a comprehensive framework for ensuring digital accessibility for people with disabilities. It's important to note that the WCAG has different levels of conformance. There's A, which is the lowest conformance, AA, intermediate, and AAA, which is the highest. A lot of organizations aim to achieve at least level AA conformance to provide a more inclusive online experience, but achieving level AAA conformance can be challenging and may not be feasible in all cases. So how can we check a website for accessibility? It involves a combination of automated testing, manual evaluation, and user feedback. So here are some steps that we can take to assess a website's accessibility. First up is automated testing. So using online tools and checkers to automatically scan the website for common accessibility issues. Some popular tools include Wave Web Accessibility Evaluation Tool, Axe Accessibility Testing Tools, and A-Checker. These tools provide reports highlighting potential accessibility structures like missing text, improper heading structure, and color contrast problems as well. However, automated tools may not catch all the issues, so manual testing is always essential. Next thing that you want to do is familiar yourself with WCAG guidelines. So get acquainted with the Web Content Accessibility Guidelines and their success criteria, and this will help you understand what constitutes good accessibility. Aim for at least level AA conformance, provide a solid baseline of accessibility, and if you can, where possible, you aim for AAA conformance. It's always good to perform manual evaluation on various aspects of a website using the WCAG guidelines as a reference. This involves testing keyboard navigations, headings, links, forms, and multimedia elements. Ensure images have descriptive alt text that conveys the purpose and content, and verify that color contrast meets accessibility and standards to make text readable for all users. Confirm that interactive elements are operable with the keyboard, and manually perform these checks as much as possible. It's also good to test with assistive technologies, screen readers like NVDA or VoiceOver, and other assistive tech to experience your website from the perspective of users with disabilities. You want to pay attention to how these technologies interpret your content and interact with your site's features. It's also good to engage real users with disabilities, so essentially invite individuals with disabilities to test your website and provide feedback on their experience. Their insights can really uncover usability issues and accessibility barriers that you might not have identified. You also want to prioritize user experience. So accessibility is about creating an inclusive user experience. Ensure that your website is not just technically accessible, but also intuitive and user-friendly for all types of visitors. Accessibility is an ongoing commitment, so regularly test and update your website for new content and features to maintain its accessibility. Any issues that come up, you want to address them promptly and keep improving your site's accessibility over time. If you have a development team, educate them about accessibility best practices. Encourage them to follow accessible coding techniques during development as well. Keep track of the accessibility improvements you've made and the issues you've addressed. This documentation can be useful for future reference and audits. And lastly, stay informed. Keep up to date with changes in accessibility guidelines, standards, and best practices to ensure your website remains compliant. Remember that achieving good accessibility is an ongoing process that requires dedication, continuous learning, and a user-centered approach. By combining automated tools, manual testing, user feedback, and a commitment to improvement, you can create a website that is accessible and usable for everyone. Accessibility testing, you also want to make sure you have some kind of website speed testing on your website as well. So what is website speed? Website speed is also known as page load time or website performance. It refers to the amount of time it takes for a web page to fully load and become usable for a visitor. It's a critical factor in determining how quickly a website's content, including text, images, videos, and interactive elements, become visible and interactive to users after they click a link or enter a web address in their browser. Website speed is typically measured in seconds or milliseconds and can have a significant impact on user experience, search engine rankings, and overall business success. A fast-loading website provides several benefits. Firstly is with user experience. So faster websites can create a smoother and more enjoyable browsing experience. Users are more likely to engage with the content or stay on a site that loads quickly, reducing frustrations and bounce rates. It also has benefits to SEO. So major search engines like Google take website speed into account when determining search rankings. Faster websites are more likely to rank higher in search results, leading to increased organic traffic. Websites that load quickly tend to have a higher conversion rate, meaning more visitors take desired actions like making a purchase, signing up for a newsletter, or filling out a form. And with the rise of mobile browsing, fast-loading websites are even more crucial. Mobile users often have slower and less stable connections compared to desktop users, making speed an essential factor for retaining mobile traffic. Quick loading times contribute to a positive perception of a website or brand. Conversely, slow loading pages can negatively impact a user's perception of a business, credibility, and trustworthiness as well. Fast loading times for websites are more accessible to users with limited internet connectivity, as well as those using older devices or browsers. Website speed can be affected by various factors, including hosting quality, server response times, page design and complexity, image and video sizes as well, and the use of CDNs as well. Web developers and site owners often work to optimize website speed by using techniques such as compressing images, reducing unnecessary code, leveraging browser caching, and using effective hosting solutions to ensure a seamless and responsive user experience. So now let's talk about the different kinds of website speed, including page load time, server speed, and other relevant metrics. So first up we have page load time, and page load time also refers to the page load speed or simply load time. This is the total duration it takes for a web page to fully load and become usable in a user's browser. And this includes the time it takes for all the page's resources like HTML, CSS, JavaScript, images, and videos to be fetched and rendered. A faster page load time results in a more satisfying user experience, lower bounce rates, and better conversion rates. And then we have server response time, and this is often called time to first byte, or TTFB, and it measures the time it takes for a web server to respond to a user's request once they've clicked on a link or entered a URL. It includes the time required for the server to process the request and retrieve the necessary data from databases or other sources and send back their initial response. A lower server response time indicates a more efficient server and contribute to a faster page loading time. So render time is the period between when a web browser receives all necessary resources from the server and when it completes rendering the entire page, making it visible and interactive for the user. It encompasses tasks like parsing HTML, applying CSS styles, executing JavaScript, and rendering images. Optimizing render time is essential for ensuring a smoother user experience. Next up, we have First Contentful Paint, or FCP. FCP measures the time it takes for the first visual element to appear on the screen as the page loads. This could be the background text, image, or other audio files. FCP provides insight into how quickly users perceive that a page is loading, contributing to their initial impression of speed. Next up, we have Time to Interactive, or TTI. TTI measures the time it takes for a page to become fully interactive, allowing users to engage with elements like buttons, forms, and links. TTI is really crucial because users expect to be able to interact with the page as soon as it's visually loaded. Next up, we have connection metrics, and these include metrics related to the process of establishing a connection to the server, like DNS resolution time. So this is the time taken to translate a domain name into an IP address. Then you have TCP handshake time, so the time taken to establish a connection, and SSL handshake, so the time taken to establish a secure connection if that's applicable. lastly, we have content delivery metrics. For websites using content delivery networks, or CDNs, metrics relate to CDN performance like edge servers response time and cache hit rate. And all of these are really important. CDNs help distribute content across multiple servers to reduce latency and improve load times. A really popular CDN to use is Cloudflare. Cloudflare is very widely used, and it can significantly improve page loading times and enhance website performance. It offers a range of features designed to optimize content delivery, mitigate security threats, and improve the overall user experience. The way Cloudflare works is that it has essential kind of global network. So Cloudflare operates a vast network of data centers located across the world. So when you use Cloudflare, your website's content is cached and distributed across these data centers. And this means that when a user visits your website, they are served content from the nearest data center, reducing the physical distance and latency between the user and the server. And by distributing content closer to users, Cloudflare reduces that time it takes for data to travel between the user's device and the server, thus resulting in faster loading times and more responsive website as well. Other than that, Cloudflare also provides a lot of security and DDoS protection. So Cloudflare's WAF, the Web Application Firewall, helps protect your website from various online threats, including malicious bots and hacking attempts. And a secure website tends to perform better since it's not dealing with security-related disruptions. In essence, Cloudflare acts as an intermediary between your website and users, optimizing the way content is delivered, improving loading times, and enhancing security. It's really important to note that while Cloudflare can provide significant improvements in your performance, the extent of improvement can vary based on factors like your website's existing architecture, content, and geographical audience distribution. So it's not just the only thing that you need to think about, but it's definitely a factor that can help. So now let's talk about website speed and user experience. So the relationship between website speed and UX and bounce rates is a really critical aspect of web design and optimization. When users first land on a web page, their first impression is heavily influenced by how quickly the page loads, and a fast page loading time creates a positive initial experience, while a slow loading page can lead to frustration and user impatience. Users are more likely to engage with the site that loads quickly, and they can start consuming content, interacting with elements, and achieving their goals without any kind of delay. Slow loading times may cause users to lose interest and abandon the site altogether. Mobile users as well, who are often on the go, rely on cellular networks, and they have even less patience for slow loading pages. Optimizing for mobile is crucial nowadays to cater for the growing segment of users. It's now one of the main ways that people come onto a site. They tend to use mobile more than desktop, so making sure that your website page and all the pages are optimized for mobile is really crucial. So with bounce rates and website speed, bounce rate is essentially the percentage of visitors who navigate away from the website after only viewing one page. A high bounce rate is often indicative of visitors leaving the site without actually engaging further. Slow loading pages can significantly contribute to high bounce rates. If users aren't met with a delay in accessing content, they might become frustrated and leave the site before exploring what it actually offers. Users have short attention spans, and they expect websites to provide immediate value, so slow loading pages can test their patience and lead to them seeking alternatives. Bounce rates have a direct impact on conversion rates. If users are leaving the site without taking any actions like making a purchase or signing up, the website's overall conversion performance is affected. To mitigate the negative effects of slow loading times on bounce rates and UX, it's essential to prioritize website optimization. And again, this includes optimizing images, minifying code, leveraging browser caching, reducing server response times, and considering the use of CDNs. Regularly monitoring and testing your website performance is key to ensuring a positive user experience and lower bounce rates. So now let's talk about how website speed affects SEO. Website speed has a significant impact on your search engine optimization. Search engines like Google consider website speed as a ranking factor because they want to deliver the best possible user experience. So here's how website speed affects SEO. Google has officially confirmed that website speed is a ranking factor in its algorithm. Websites that load faster are more likely to rank higher in search engines, and Google aims to provide users with fast and relevant search results, so it rewards websites that offer better loading times. Search engines prioritize websites that provide a positive user experience. Slow loading websites frustrate users and discourage them from staying on the site or returning in the future. As a result, search engines want to promote websites that load quickly to ensure users have a smooth experience. Slow loading pages tend to have a higher bounce rate, which refers to users leaving a website after a short while. And high bounce rates can signal to search engines that the content on the page might not be relevant or the user experience is poor. Conversely, fast loading pages leads to a longer dwell time, so the time users spend on a page, indicating higher engagement and satisfaction. Search engines also allow a crawl budget to each website, which determines how often search bots crawl and index a site's page. A slow-loading website may consume more of its crawl budget on loading pages, leaving fewer resources for crawling and indexing the most important content. And with mobile devices becoming the primary way users access the internet, Google has shifted to mobile-first indexing. This means that Google primarily uses the mobile version of the content for indexing and ranking. Mobile friendliness, which includes fast loading times on mobile devices, is crucial for SEO. Core Web Vitals are a set of user experience metrics that Google considers essential for determining page experience, and these metrics include largest contentful paint, so LCP, first input delay, FID, and cumulative layout shift, CLS, which measures loading performance and it's particularly important for website speed and SEO. To improve website speed for better SEO, steps that you can consider are optimizing images, so essentially compressing images to reduce file sizes without sacrificing quality, removing unnecessary code, leveraging browser caching, and optimize server response time, so ensure that your hosting provider can respond quickly to user requests as well. By prioritizing website speed, you're not only improving user experience, but also boosting your website's chance of ranking higher in search engines, driving more traffic to your website. So let's talk a bit more on how to improve your website speed, and this involves a combination of optimizing various aspects of your website, including code, images, server configurations, and a lot more. First thing that you want to do is conduct a speed test, and we'll talk a little bit later on how to do that, but you want to use online tools like Google PageSpeed Insights, GTmetrix, to analyze your website's current performance. These tools provide insights into what elements of your website are slowing it down. Images are often a significant contributing factor to slow loading times. Compress and resize images before you upload them to your site, and considering using modern image formats like WebP, which offers better compression without actually compromising the quality. Removing unnecessary whitespace comments and code from your CSS, JavaScript, and HTML files. This seems small, but it does reduce the file size and makes them load a lot better. Configure your server to set expiration dates for the static resources, and this allows browsers to cache these resources so returning visitors don't need to re-download them. CDNs distribute your website's content across multiple servers worldwide, and when a user requests a page, the server closest to them delivers the content, reducing latency and load times. You want to enable gzip compression on your server. This compresses your website files before sending them to the user's browser, reducing data transfer times. Ensure your web hosting server is responsive, so if you experience slower server response times, consider upgrading your hosting plan or switching to a more reliable hosting provider. For more information about some good hosting providers that are out there, we do have quite a few videos comparing different hosting providers, especially for e-commerce websites, so make sure you give that a go. Each redirect that you have adds additional time to the page load process, minimizing the use of redirects or ensuring that they are necessary for the user experience or SEO purposes. And if you're using a content management system like WordPress, consider using caching plugins. These plugins generate static versions of your pages to reduce server load times and improve load times as well. And most importantly, continually monitor your website speed using various tools and conduct regular performance tests. So it's not enough just to do it once and make improvements. You want to have a set schedule to conduct a speed test and see if there's any new issues that come up, especially if your website has lots of content on it that's constantly being uploaded and being worked on. You want to make sure that you do a speed test every so often to highlight new issues and fix them as soon as possible. Each website is unique, so the specific optimizations required can vary. It's recommended to make these changes one at a time, test the impact after each change, and keep track of your website's performance to ensure you're headed in the right direction. So once you have your application readily tested, how do you actually deploy your web application? Deploying a web application just simply means making your application accessible to users on the internet. The exact process can vary on the technology stack that you're actually using, but here's a general guide. The first thing that you want to do is prepare your application. So you want to ensure that your web application is fully tested and ready for deployment. All features need to work as intended, and any sensitive information like database connection strings should be appropriately secured as well. Next, you want to select a hosting provider that suits your need. Some common options include cloud services like AWS, Google Cloud Platform, Microsoft Azure Apps, and platform as a service providers like Heroku or Netlify. Then you want to set up a server if you're not using PaaS solutions. So think PaaS means just platform as a service. You need to set up a server to host your application, and that might involve configuring a virtual server on a cloud provider or using a dedicated server as well. You want to choose and register a domain name for your web application. If you want to, and you should, secure application, you need to obtain an SSL certificate for HTTPS. A lot of hosting providers will offer integrated solution for domain registration and SSL certificates like GoDaddy. If your application uses a database, you need to ensure that it's properly configured on the server. This might involve setting up a database instance and importing your web application data. And then you want to configure your web server to serve your application. So set up any necessary server-side configurations like environmental variables. And then you want to upload your application code and any required assets. Check for any issues that might arise from the differences between development and production environments, and implement some monitoring tools to keep an eye on your application's performance and user activity. Consider implementing auto-scaling if your hosting provider supports that, because it's going to help you handle different levels of traffic and different fluctuations as well. Set up regular backups for your application database to ensure data integrity and the ability to recover from any kind of